In this section, 2.R.6, we're going to learn about solving linear equations. You probably know what an equation looks like. It's got an equal sign. But linear has that root line, and we're going to see why it's called linear a little later on in the semester. But in particular, in this section, we're looking at equations of the form ax plus b equals c, where x is a variable, and the a, b, and c are all going to be specific numbers, integers, fractions, decimals, something like that. Now, the procedure, if you want to pause and copy this down, you're not going to need to write this or even really say what these things are. But these are the 4 steps. The first is to combine like terms, if possible. Then we'll use the addition property, which is the addition property of equality, is that we can add the same things, add the same number to both sides of the equation and have an equivalent equation, getting us closer to the solution. The next step is to use the multiplication principle, or multiplication and division principle, to multiply or divide to get rid of the coefficient of the x and to get the x by itself. That isolating of the variable on one side of the equation gives the solution on the other side, and then we can check the solution by putting it into the original equation. I'm not going to do that with this, but this is the form of the equations we'll look at, roughly. So for the first example, I have 6a minus 8 equals 11. And then an arrow. This is what Hawks gave me. With 6a minus 8 plus 8 equals 11 plus 8. That's why I mentioned the addition property of equality. This isn't asking us to solve it, it's asking us what property. Why is this true? And what's happened here is with the 6a minus 8 equals 11, I've added 8 to both sides of the equation, and that keeps it balanced, has the same solution. But the reason would be so that I can cancel that 8. Getting me one step closer to isolating the variable. That's not what this problem is, though. They say, why is this true? And the answer is the addition principle of equality. There may be 1 or 2 problems like this where you have to fill in the bubble. It's not because of the multiplication principle. We didn't multiply, but we added, and we still have an equivalent equation. The second problem is more typical of the problems in this section. We're going to solve. The equation is negative 3x minus 9 equals 0. And the first step in that list was to combine like terms, but there are no like terms here. There's a number term and there's a variable term. There's only a number term on the other side. But the next step, actually the addition principle of equality, or just the addition principle, is that I can add 9 to both sides and end up with negative 3x. Minus 9 plus 9 cancels each other. You can even mark those out if you want. But what's left is just this negative 3x on this side. 0 plus 9 is 9. And finally, I can divide by negative 3 on both sides to get x equals negative 3. 9 divided by negative 3 is negative. 9 divided by 3 is 3. So there's my solution, and that's what I need to put in. I do want to mention step 4, which is to check. You don't have to check. You already have the answer. But checking allows you to be sure that that's the answer before you submit it or use it for the next step or something. we can make sure it's correct by plugging it into the original equation, negative 3. X is negative 3. So I'm substituting negative 3 in place of that x. Minus 9. And I'm going to say question mark equals 0. Is it equal to 0? It is equal to 0. If I do negative 3 times negative 3, that's 9. Minus 9 equals 0. And there's no question about that. 9 minus 9 is 0. So it checks out. And that's how I do my checks. I label them usually, and then I show, or if the check doesn't work, I need to go back and re-examine the problem, maybe try it again. The third one is another solve problem. 2w plus 3 equals 17. And for this one, again, there are no like terms to combine, either over here or over here. So I'm going to start with subtracting 3 from both sides. I get 2w left on this side, and 17 minus 3 is 14. Now I can use the multiplication principle, or division principle. It's really multiplying by 1/2, but it's easier to write divided by 2 on both sides. So the 2's cancel, I get w. Over here, 14 divided by 2 is 7, and that's it. That's the solution. The check, which is worth doing, even though Hawks will tell you if you're right or wrong, it's worth practicing checking, because when you practice the check part, you get faster and better at it. And you can use that in a timed testing environment. So if you're not so good at checking, you probably wouldn't want to do it in the test because you'll run out of time. Practice makes faster, or whatever they say. So in this case, yeah, I want to plug in the 7. 2 times 7 plus 3, and check, is that equal to 17? That's 14 plus 3, and yes, that is equal to 17. This one checks out. So this is the solution. For number 4, I'm probably going to stop checking most of these, though. You could do that on your own to practice evaluating expressions, but to get this list of problems done in a timely manner, I'm just going to solve them. 3x plus 8x minus 14 equals 30. 3x plus 8x minus 14 equals... Yeah, so this one I actually do have that first step. I can combine like terms first. 3x plus 8x is 11x. Minus 14 equals 30. Now I'm going to add 14 to both sides to get... Let's go up over here so I can work downward. But 11x is still there on the left, but that's it, because minus 14 plus 14, that's all gone. 30 plus 14 is 44. And then finally, I can divide by 11 to get x equals 4. The next one I got is kind of long. So I want to do this in a more time-saving way. Maybe we'll work with fractions on a later one, but for this one, it takes a long time to do it with just adding together the fractions and getting common denominators each time. What I'm going to do is another way, and I'll do it both ways later on. But with this problem, because there are so many fractions, I want to demonstrate the technique of multiplying by the LCM to clear the equation of fractions in one step. then the rest of the steps will be actually pretty quick. So the LCM, let me build it over here. The LCM, the least common multiple of all the denominators. The LCD, or lowest common denominator, that's exactly the same number for all four of these fractions. Now I'm going to go through them one at a time and just pick up the prime factors that I need to build the LCM it's a quick way. That's what it is. It's more graceful too. So I do need a factor of 3. And I need a factor of 5, but I already have a factor of 3. I don't need another factor of 3. I need a factor of 2. And that's it. I already have a factor of 2 and a factor of 5, so I don't need another one. This is the least common multiple, or lowest common denominator. You can get a common denominator by multiplying all 4 of those denominators, and you'll have a big number. It'll work, but it's a lot of work to work with larger numbers. The least common multiple, what is that? 15 times 2 is 30 is the least common multiple. And that's what I'm going to do. Multiply the whole side of the equation by 30. So 30 times on that side, also times 30 on this side. That's the multiplication principle that I'm using. It's not really the steps for solving that simpler equation, but we do the same thing to both sides, and let's see what happens. This 30 needs to be distributed to all 3 of these terms. So I'm going to do that one term at a time. 30 times 13 over 3. Actually, we could write it out. 30 times 13 over 3a minus 30 times 2/15 a plus 30 times 30 times 7 halves. No a, no variable on that part. I'm going to have to erase my work for the LCM here. But it's equal to, well, this is already written as a single product of 2 numbers. We could actually start to work with this. 10 and 30 have a common factor of 10 that I can cancel out, that'll leave a 3. So this side is really 9 times 3. Once I cancel that 10. Now I'm going to come back and start working through these terms and canceling these also. The 3 and the 30 cancel, leaving a 10. So I have 10 times 13a. The factor of 3 up here. And the factor of 3 down here. Leaving just 10 times 13a. Minus the 15 and the 30 cancel. Leaving a factor of 2. Because 30 divided by 15 is 2. And then there's this other 2a. Plus the 30 and the 2 cancel. Leaving a factor of 15. 15 times that 7. And 9 times 3 is 27. So now you can see the advantage of multiplying by that number 30. It canceled out all the denominators. There are no more fractions. We could have fussed around with fractions at every step. I did it that way. It took like 9 lines. I think we're going to get it done in like 5 here. So it's significantly shorter. 10 times 13a is 130a. Minus 2 times 2a is 4a. Plus 15 times 7. I can do this. 105. Thank you. Yeah, 105 equals 27. Now is where we really get to that list of 4 steps. I've got everything kind of each term simplified, but now I can combine the like terms of 130a minus 4a is 126a plus 105 equals 27. So there's combining like terms. Now I'm going to use the addition property. What's really going on there, I think of it as subtracting 105. We're adding negative 105. same idea. But that gives me 126a on the left and negative 78 and now I need to divide by 126 on both sides. Bring that back up to the top because I am going to simplify this fraction. Sometimes Hawks is flexible. It will let you put the fraction, decimal, integer if that's the case, but it'll give you a choice. I'm going to find the simplified fraction. That brought me down to the 126's cancel. I just have a equals negative 78 over 126. They're both even. This is negative 39 times 2, and this is 63 times 2, so I can cancel those 2's. And I don't know these numbers really well, so I'm kind of factoring them a little at a time. I know they're both even, so I can factor out a 2. Now, both of these are multiples of 3. Negative 13 times 3 and 21 times 3. And if I cancel those factors of 3, I get negative 13 21sts. That should be, yeah, negative 13 21sts is the solution. And you can check that. The thing is, if you're going to go back to the original equation and check that, you are going to have to deal with fractions in order to check. And it takes about as much time as it does to solve the problem. This next one is an applied problem, but I'm just going to read it because you don't actually have to build the equation from the paragraph or from the sentences that they give you. They give you the sentences that describe the situation, and they give you the equation. Later on, we're going to have to build our own equations based on descriptions, verbal descriptions. But for this one, they say, number 6. They say that tickets for a concert sold out in 5 hours. If 35,000 tickets were sold, find the number sold per hour. 35,000 altogether, 5 hours, that was it. How many per hour? And they don't actually tell you to build the equation. They give us 35,000 minus 5x equals 0, where x is the number of hours that it took. No. X is the number of tickets sold per hour. 5 is the number of hours. So the 35,000 tickets sold in 5 hours, 5 times the hourly rate of ticket sales should make this left-hand side equal to 0. But they gave us this equation. We have to solve it. I'm going to do the minus 35,000 from both sides. The number's big, but the principle's the same. Negative 5x is what's left on the left-hand side. And then negative 35,000. I'm going to put commas. It's readable. And then divide by negative 5. So it's x equals negative and negative cancel. 35,000 divided by 5 is 7,000. 7,000 tickets per hour in this context. But I think all I had to type in was the 7,000. The next one is a temperature conversion, and we've seen this equation before. What is the Celsius temperature for 98.6 degrees Fahrenheit. And they give us this expression 1.8 C plus 32 equals 98.6. So the 98.6 is the Fahrenheit degree temperature. The rest of this is kind of a conversion equation. Now, if we knew what the Celsius temperature was, we could multiply it by this and add 32 and get whatever the Fahrenheit temperature is. It's the same temperature, it's just two different scales of measurement. Here, though, we have the Fahrenheit, we need to find the Celsius, and so we just need to solve this linear equation in one variable. Subtract 32 from both sides to get 1.8 C equals 66.6. Yeah, and then divide both sides by 1.8. And that gives C on this side. C is isolated. And 37 degrees on this side. I'm going to put 30. Oh, no, I'm not going to do that. Never mind. I'm not going to put 37 degrees Celsius because there's already a C here over, and I don't want to say C equals 37C. Oh, we can do it this way. 37 degrees Celsius by spelling out the word so as not to confuse it with the variable. But that's the same temperature as 98.6 degrees Fahrenheit. 37 degrees Celsius is 98.6 degrees Fahrenheit, just different measurement scales. This equation is based on the conversion formula. Number 8 says 8u plus 2 equals negative 16. And that's where we start by subtracting 2. So 8u equals negative 18. And then divide by 8. So u equals, 18 and 8 have a common factor of 2. I don't know if that's the only common factor, but yeah, because it's negative 9/4 if I cancel that factor of 2. That's the solution. You could also write negative 2.25, negative 2 1/4, writing it like that. Don't do it as a mixed number, 2 1/4. Hawks won't accept it. And it's actually not even good in algebra, because in algebra, when you write numbers like this, it means 2 times 1/4, because you put things next to each other to multiply. Improper fraction is a better way. Decimal is okay too. It should be negative anyway, but yeah, don't do it as a mixed number. This is good in commerce, when you're exchanging, buying, selling, that sort of thing. This is a great way to do it. But in algebra, it's much better to have the improper fraction. And it's all right to have the decimal too. So for the next one, it's also a solve it problem. 8 plus 1 equals 6x plus 9. It's kind of weird. They just got these two numbers here that I can combine like terms, though. They are the same terms. 9 equals 6x plus 9. Might feel a little bit strange, but I'm going to subtract 9 from both sides and get 0 equals 6x. That's okay, though. We just continue with the next step, which is to divide by 6. 0 divided by 6 is 0. So I would say it like this: x equals 0 is the solution for that one. And you can plug that in. 6 times 0 is 0, and you can actually check it without even writing. 1 plus 8 is 9, so it checks out with x equals 0. For number 10, it's got a fraction problem, 11/6 y minus 4/3 equals 11/3. Yeah. Yeah, and I'm going to do this one in a straightforward way, rather than try to be slick and clever about it. Well, you can do that. Do it that way if you want. You multiply both sides by 6. That's the LCM method. Here, though, it doesn't give us too much help. And I do want you to see that you can just work with fractions. It's just the more fractions there are, the longer it takes. In this case, there's 3. If I add 4/3 to both sides, I get 11/6 y equals 11/3 plus 4/3 is 15/3. And then, before I go on with that, I do want to simplify this fraction. I can't simplify that one, but if I simplify this one, I won't have to do it again later. 15 divided by 3 is 5. And then, to get rid of the 11/6 coefficient, you can multiply by 6 to get rid of the 6 on both sides, and divide by 11 on both sides to get rid of the 11, to get the y isolated. But it's more efficient if you multiply by 6/11ths on both sides. The reciprocal. Multiplying by the reciprocal makes it go away. And because of the property, the principle of multiplication for equations, or the multiplication principle of equality, I can do that to both sides. I can just multiply by the reciprocal and get rid of it. Well, I get rid of it on that side. 11/6 y times 6/11ths is y. And 5 times 6/11ths, well, I'm going to write that down. 5 times 6/11ths. We can think about how to do that separately. Is there any common factor that we're going to be able to cancel at all? There isn't. 11 is the only factor that's in the denominator, and there's only 2, 3, and 5 as factors of the numerator. What I can do is think of this as 5/1, and just multiply the fractions to get 5 times 6 is 30, 1 times 11 is 11. And that's the answer, 30/11ths. If you put it in as a decimal, I believe you have to round to 2 decimal places in Hawks, but 2, 3 decimals, that's usually plenty. For 11, I got 2.3x minus 1.31x minus 3.74 equals 3.96. This looks like to me that it came from a money situation, because this $1.31 and $3.74 and $3.96. I mean, this you could think of as $2.30. Looks like a financial problem. It does have that first step thing where we've got like terms we can combine. 2.3x minus 1.31x. I put that in the calculator. It's 0.99x. Minus 3.74 equals 3.96. So I just combined those two like terms for the first step. Now I'm going to add 3.74 to both sides. So it goes away over here. There's just 0.99x. And over here, 7.7. And finally, dividing by 0.99 on both sides. They cancel over here and I get just x. Over here, 7.7 divided by 0.99 is 7.777777. And it keeps going with 7s. So wherever I stop, the next one's going to be a 7. So I should round that one up to an 8. So that's the good way to round, but this is too many digits. For Hawks, we would have to put it as 7.78. Round it right there at the second decimal place, because they want 2 decimal places. For my number 12, I got negative 6.4 equals 0.3z minus 1.2z plus 3.5. And again, I can combine like terms here. They're on the same side of the equation. When I move things across the equation, that's when we're actually doing the same thing to both sides of the equation. Those are the principles of multiplication and addition. Right now, I'm just combining 2 like terms. I'm just subtracting, actually. It's not one of those principles of working with equations. It's just that negative 0.3z minus 1.2z is negative 0.9z. So I just combine those 2 like terms. Now I'm going to subtract 3.5 to get rid of that part of the side with the variable. These two combine to negative 9.9 equals negative 0.9z. And then finally I can divide by negative 0.9 to get z isolated on that side. And positive because it's negative divided by a negative. 9.9 divided by 0.9 is 10. That's not. That's what it is. In fact, you might even be able to do this without a calculator. If you think about 9.9 over 0.9 as moving the decimal place to the right on both of them. That's multiplying by 10 up here and 10 up here. It's 99 over 9. 99 is 9 times 11. So if I cancel the 9, it leaves the 11. And that is arithmetic. For number 13, negative 17 equals negative 2v minus 13. This is really the 2 principles of equality that are going to solve this for us. First, the addition principle. To add 13, I get negative 4 equals negative 2v. Yeah. And then divide by negative 2 on both sides. I get 2v, or v equals 2. For 14, I have negative 19 equals negative 3u plus 10. Another kind of a 2-step problem. No like terms to combine. I can just subtract 10 from both sides, getting negative 29 equals negative 3u. And then dividing both sides by negative 3. They cancel over here, leaving u. The negatives cancel, but 29/3 is reduced. There are no, 29's prime. It doesn't have a factor of 3. And then finally, number 15 is 56 plus 74 equals 41x plus 86 minus 83x. So a combined like term situation. On the left-hand side with these numbers, and on the right-hand side with these variable expressions. I'm going to do both in the same step to save some writing. 56 plus 74 is 130, and that's equal to 41x minus 83x. I'm going to combine these like terms. That's negative 42x. And then this plus 86 doesn't have a like term. It's just still there. That is the first thing that I work with in the next step, though, is I'm going to subtract away the 86, trying to get my variable alone. This gives me 44, and it equals negative 42x. And then finally, I can divide by negative 42. Let me get rid of the 42s, but also turn the equation around forward. So it's got x equals 44 over negative 42. We need to simplify this part. It's negative, and the negative should either go in front of the whole expression, in front of the fraction, or in the numerator. In the denominator, it's not considered simplified. So the negative should either be in front of it or in the numerator. But for this one, 44 and 42 have a common factor of 2 is one of them. They're both even numbers. So it's 22 over 21. And those don't have common factors. 21 has factors 3 and 7. 22 has factors 2 and 11. Nothing in common. That's it. That's the reduced form. So what I was saying earlier is that you can also usually write it like this. Same number. The difference is here I've put the negative in the numerator, and I think Hawks will accept that. That's generally considered an acceptable form. So is the negative sign in front. But the negative sign in the denominator is not considered simplified, especially by Hawks. So you need to do not just the removing common factor, but also putting that negative somewhere else. And with this problem, you can put it as a decimal rounded to 2 digits as negative 1.05.